All right, hey, starting chapter 6. This lesson is just an intro to the systems of differential equations. Let's start with the first example, which says to show that the ordered pair of functions, f1 and f2, where f1 of t is 3e to the 2t plus 4e to the 3t, and f2 of t is 6e to the 2t plus 4e to the 3t, that these are for all t, right? So this ordered pair of functions for all t is a solution to the system of x1 prime equals 4x1 minus x2, and x2 prime is equal to 2x1 plus x2. Okay, so keep in mind, this is just, this f1 is this x1. Well, it's this x1, and then it's x1 prime would be the first derivative, you know? And then f2 is x2, and x2 prime would just be the derivative of f. So that's what we're going to do. We just want to confirm that these two functions are a solution to this differential system of differential equations. So let's start by finding the first derivative of f1. Taking the derivative of this guy, you would bring that chain rule would say times 2, so it would be a 6e to the 2t plus 12e to the 3t. And do the same thing with f2. Take its first derivative, which will give you 12e to the 2t plus 12e to the 3t. And then what we want to do is substitute these values into these two equations and make sure that both of them have to be satisfied for it to be a solution to the whole system. So let's substitute into the first equation. And just to be clear, x1 prime means f1 prime. x1 means f1, and x2 means f2. That's all. So plugging those in, we've got 6e to the 2t plus 12e to the 3t. We want to confirm, is this equal to 4 times f1 and then minus f2? And I made sure to put parentheses in there because remember, you're subtracting the whole thing, and so those negatives gets distributed. This negative gets distributed to both. So let's simplify this. This is a 12e to the 2t plus 16e to the 3t. So I distributed the 4 into both of those. Distribute the negative. You have negative 6e to the 2t minus 4e to the 3t. And then combining like terms, e to the 2t, e to the 2t, that gives you 6e to the 2t. And then 16e to the 3t minus 4e to the 3t will give you a 12e to the 3t. Matches. All right, so it definitely satisfies the first equation, but for these two functions to satisfy this system, it needs to satisfy both equations. So you definitely need to substitute it into the second equation also. And the second equation says slide it down a little bit, x2 prime, all right, that means f2 prime, is it equal to 2 times f prime plus f1 plus f2. x1 replacing with f1, x2 replacing it with f2. This guy is f2 prime. All right, so f2 prime we said was 12e to the 2t plus 12e to the 3t, and we want to see, is this equal to 2 times f1, which was 3e to the 2t plus 4e to the 3t, plus f2, which was 6e to the 2t plus 4e to the 3t. Distributing the 2 inside here. And adding those guys. combining like terms now. The 2t's, you got 6 plus 6, so 12 e to the 2t. And then 8 and 4 is 12e to the 3t. And so sure enough, we have definitely verified or shown that this ordered pair of functions definitely satisfies this system of differential equations. All right, let's do another example. It's going to be a word problem, and I'm not going to rewrite all of that. There we go. All right. Let's get this situated over. Okay. There we go. All right, so it says, example 2. A tank initially contains, do you remember, we did these tank type problems back in, I think it was chapter 1. A tank initially contains 100 gallons of a salt solution with 20 pounds of salt. And a second tank contains 25 gallons of a salt solution with 10 pounds of salt. So I'm going to draw 2 tanks. First one I'm going to call X1, and it's got 100 gallons in it of a salt solution, and it's got 20 pounds of salt. So X1 at 0 is 20 pounds. So that's the initial amount, right? And then tank 2 has some amount in it. I'm going to call it X2, and it contains 25 gallons of a salt solution with 10 pounds of salt. So there's 25 gallons of solution in there, and how much salt to begin with? 10 pounds. Yeah, all right. So those are our 2 tanks, but then some fluid starts going in and out of these tanks. So water flows into the first tank at a rate of 1 gallon per minute. So I would show like an arrow saying, okay, 1 gallon per minute of water is going in. Water. Okay. Do you remember that how we set up these differential equations is the change in your x, the change in the amount over time will be how much is coming in and then subtracting anything going out. But what you had put in each of these things were the rate, well, I got rate, 1 gallon per minute, but times the concentration. And on each of these boxes, for each of them, you would go, okay, how much is going in? Rate times concentration. So the concentration is going to be a ratio of how much salt per the gallons of that are in there, right? And so how much salt is in water? Well, theoretically none. So anytime there's water, you're going to say there's 0. So 0 pounds per gallon is going to be the concentration of that guy. All right, then, okay, so that's the water. Water flows into the first tank at a rate of 1 gallon per minute. Liquid is pumped from tank 1 into tank 2 at a rate of 2 gallons per minute. So we've got flowing from tank 1 to tank 2 at 2 gallons per minute. And how much is the concentration? Well, it's X1 over 100. And it's X1 pounds over 100 gallons. Just keep our units correct, right? That's the concentration. And then the 2 gallons per minute is the rate. Okay, and then liquid is pumped from tank 2 into tank 1. Oh, I wish I wouldn't have written that right there. Darn it. Okay. We're going from tank 2 to tank 1 at a rate of 1 gallon per minute. And how much? Well, the concentration will be X2 over 25 gallons. So it'll be X2 pounds over 25 gallons. That's how much is being pumped from tank 2 into tank 1. And liquid is pumped out of tank 2 at a rate of 1 gallon per minute. And how much would be going out? X 2 pounds over 25 gallons. All right, so there's our little thing. Yes. Okay, so now we're going to use this where we do the change in the amount over time is how much in, and for each of the ends, it's rate times the concentration. Subtract anything going out, again, for each of them, rate times concentration. So for x1, I'm just, instead of writing dx1 dt, I'm just going to write x1 prime. So the change in x1 is going to be, all right, so you got going in 0 pounds per gallon times the rate, which is 1 gallon per minute. We've got that going in, so that's positive. Going out, so subtract, we'll have x1 pounds per 100 gallons times the rate, which was 2 gallons per minute. And then we also had it pumping from the tank 2 into tank 1. So we've got this guy also, and it's coming in, so a plus x2 pounds per 25 gallons times 1 gallon per minute. And of course I'm going to simplify those, but before I do, let's write out the second one. So the change in x2. All right, so tank 2, we've got this guy coming in. So it would be x1 pounds per 100 gallons times 2 gallons per minute. We've got going out this guy, which was, so minus x2 over pounds per 25 gallons. That's the concentration. The rate is 1 gallon per minute. And then we also having going out from tank 2 to tank 1, we also have coming out x2 pounds per 25 gallons times its rate, which is 1 gallon per minute. All right, let's clean this up. This ends up just being a 0, right? So your x1 prime would be 0. When you multiply these two together, it'll be a 2 over 100, a negative in front also, but 2 over 100 will give you 1 over 50 times x1. And I'm going to get rid of I'm not going to show the labels, right? And then this guy would be what? Plus 1 over 25 x2. Second one would be the change in x2 would be, what is that? 1 over 50 x1. And then minus 1 over 25 x2. And this one's also a minus 1 over 25 x2. So it ends up being a minus 2 over 25 x2. All right, so we're going to stop here because it's just an intro and you don't have the tools to solve this yet. You will by the end of the chapter, but as of right now, you do not have the tools to solve this. If one of these equations had just one of the functions in it, right? And in fact, you'll see that in the next section. Like, you know, if I only had just one of them, I could then solve for one and then plug it into the other, and then it's solvable. But the way this stands right now, you don't have the tools yet. All right, just an intro. That's it. Easy peasy, lemon squeezy. Bye.